Imagine looking up at the night sky. For all of human history, we've seen those same twinkling lights, told stories about them, and used them to navigate. But what if we could see more? The James Webb Space Telescope, or JWST, is humanity's most powerful time machine, a golden eye sent 1 million miles from Earth to look back to the beginning of everything. Its primary mirror, over 21 feet across and made of gold-coated segments, collects faint, ancient light that has traveled for billions of years. This light is a message from the past, a ghostly echo from when the first stars began to ignite. The JWST is our messenger, capturing these whispers from the dawn of time and translating them into the language of light and data. Think of the universe as a vast ocean. For centuries we saw only the surface. Now, with JWST, we can dive deep into the hidden depths. It can see through clouds of dust and gas, revealing secrets long hidden from us. Launched on Christmas Day 2021, JWST traveled to a special point in space called L2, where it can stay stable and keep its instruments cold. From this outpost it patiently gathers photons that began their journey when the universe was just a toddler. The JWST isn't just observing, it's participating in a cosmic dialogue, asking the deepest questions and listening for the universe's reply. With JWST we're not just looking at the stars, we're uncovering our cosmic origins. The Hubble Space Telescope was our champion, showing us the universe in visible light. But Hubble has its limits. It can't see through thick cosmic dust or capture the most ancient stretched light. Enter the James Webb Space Telescope, designed to see the universe in infrared. Infrared is invisible to our eyes but can be felt as heat. As the universe expands, ancient light stretches into infrared, and JWST is built to capture it. While Hubble gave us the visible universe, JWST reveals the hidden, infrared universe, like putting on superpowered goggles. Imagine a dusty room with normal eyes, you see nothing, but with infrared goggles, you see what's hidden. That's what JWST does for astronomers. It peers through cosmic dust clouds, revealing the fiery nurseries where new stars and planets are born. This ability to see in infrared is a game-changer, unlocking secrets only visible in this spectrum. From exoplanet atmospheres to the hearts of colliding galaxies, JWST is filling in the missing pages of our cosmic photo album. It's not just about seeing farther, it's about seeing differently. The universe is full of secrets that only JWST can reveal. Until now, these pages were blank because we lacked the technology. The JWST is not just an upgrade, it's a revolution in our ability to perceive the cosmos. We're finally seeing the universe as it truly is, hidden wonders and all. One of science's greatest quests is the search for first light, the moment, a few 100 million years after the Big Bang, when the universe emerged from darkness. After the Big Bang, the universe was a hot, dense soup, then cooled into darkness with no stars or galaxies. Then, gravity pulled matter together, igniting the first stars and piercing the darkness. JWST was built to capture the faint reddish glow of these first galaxies, the ancestors of our Milky Way. Finding them is like cosmic archaeology, digging through time to unearth the universe's foundations. Before JWST, we had only blurry hints from Hubble. Now, we have clarity. In its first year, JWST spotted candidates for these early galaxies, seen as they were just 300–400 million years after the Big Bang. These objects are incredibly faint and distant, their light traveling over 13.4 billion years to reach us. They're more than dots of light, they're time capsules. By studying their light, scientists can learn what they were made of and how the first stars and galaxies formed. Were the first stars massive and short-lived? How did they create the elements essential for life? JWST is providing the first real data to answer these questions. It's turning our theoretical sketches of the cosmic dawn into a detailed portrait of the universe's birth. Here's where the story takes a turn, where observation challenges theory. Our best models predicted the first galaxies would be small and clumpy, taking billions of years to grow into giants. But JWST found galaxies that were massive, bright, and well-formed just 500–700 million years after the Big Bang. It's like finding a fully grown adult in a kindergarten class photo. These discoveries are shaking up cosmology and astrophysics. The standard model, lambda CDM, predicts a slow, bottom-up process of galaxy formation. Yet JWST's data shows massive galaxies appearing much faster than expected. These aren't rare outliers. JWST is finding them again and again. Are our ideas about gravity, dark matter, or star formation incomplete? Whatever the answer, JWST is forcing scientists to rethink the universe's first chapter. Our understanding of the universe is built on a cosmic recipe: 5% normal matter, 27% dark matter, and 68% dark energy. This recipe, the Lambda CDM model, has been our foundation. But JWST's discoveries of massive, mature galaxies so early suggest the universe was more efficient at building structures than we thought. Maybe our measurements of dark matter and dark energy aren't quite right, or their properties change over time. Perhaps dark matter isn't as cold as we assumed, or there are new interactions we've never considered. JWST's findings are pushing theorists to explore radical new ideas, even questioning if the laws of physics have always been the same. The telescope isn't just taking pictures, it's testing our most basic assumptions about reality. The JWST isn't just answering old questions, it's inspiring new, deeper ones. The biggest: how did the universe build such massive galaxies so quickly? Did our models underestimate the seeds of galaxies, or was star formation wildly different? How did early galaxies interact, through smooth gas accretion or dramatic mergers? JWST's images help us look for clues in this unexplored territory. Ultimately, are our fundamental laws of physics truly universal and unchanging? JWST is probing the very nature of reality, asking questions that challenge our deepest understanding. These discoveries may seem distant, but they're fundamental to understanding our place in the cosmos. Every atom in your body, except hydrogen and helium, was forged in ancient stars. The story of the first galaxies is our own cosmic family history. Science advances by finding out where it's wrong, and JWST's data is a spectacular opportunity. It pushes us to be more creative and rigorous. This is how breakthroughs happen. Building JWST required innovations in optics, cryogenics, and data processing, with benefits that ripple into everyday life. More importantly, it inspires a new generation of scientists and thinkers. When we see what humanity can achieve together, it gives us hope and a sense of shared purpose. Understanding the universe helps us understand ourselves and the preciousness of our world. The questions JWST raises about origins, the laws of nature, and life elsewhere are not just scientific, they're deeply human. They speak to our need to find meaning in the vast, mysterious reality we inhabit. What comes next? JWST is just beginning its mission, and the most exciting discoveries are yet to come. One frontier is the study of exoplanets, analyzing starlight passing through their atmospheres for signs of life. JWST could be the first to find evidence of a habitable or even inhabited world beyond our solar system. Astronomers will use techniques like gravitational lensing to look even farther back in time, seeking the birth of the very first stars. Each new image adds to our story, revealing new details about our cosmic origins. The story of JWST is about human aspiration, our refusal to be content with the darkness. We build magnificent machines, send them to the heavens, and ask our questions. The next chapter of the human story is being written now, in the light of distant stars.